Hi, welcome to Bennington. I'm Mike. I'm going to be talking with you today about Bennington production and some manufacturing practices and show you some things that we do. For those of you that aren't familiar with Bennington, we started in 1997. We were a true startup company. We weren't a company that bought another brand and changed the name and changed the logos. At that time in 97, nobody knew what a Bennington was or had any idea that we would grow into an industry leader and basically dominate the pontoon world the way we have. In 1997, when we started, the pontoon industry was pretty stagnant. So we had an opportunity with the key people that we had and the ideas that we had to build a better pontoon boat, make it stylish, make it fun, and eventually it evolved into what you see today on the lakes and the rivers from Bennington. High performance, high luxury, high quality pontoon boats that go fast and are fun and look great. Certainly not your grandfather's pontoon boat. So come with me and we'll check some things out in the plant. We're starting our tour in the tube fabrication plant, or what we call here the North Building, which was actually the first building when Bennington started. All of our operations were in this building, but at that time it was about a third of the size. As you look around, you see lots of stacks of flat stock aluminum. We build tubes that range in length from 16 feet long to 30 feet long, diameters 23, 25, and 32-inch elliptical, and wall thicknesses that are 080, 0.1, or 0.125, which is an eighth of an inch thick. Depending on what the boat calls for and where the boat's going to be used and what kind of engine it's going to have, that's going to dictate what tube thickness we use. But regardless, they're all going to be manufactured the same way. They're all going to be used, rolled on these two rollers, and then once they're rolled, they're going to be seam welded with a robotic welder. Everything else on a Bennington is a hand weld, with the exception of the tube sidewalls being seamed at the top. Once the workers roll the flat stock aluminum, it's going to come off in a tube shape coil like this with the two loose ends. The next station, the worker's going to put the tube section on the robotic welder, and the robotic welder is going to actually create the weld along the top of the tube that holds the two loose ends of the tube together. So this is what the robotic welder does for us. It takes the two loose ends of the tube sidewall and welds them together nice and even and consistently. By design, it leaves about 6 inches at the top and at the bottom of the tube unwelded, so the worker in the next station has the ability and some flexibility with the aluminum to insert an end cap or a baffle, which allows us to seal off the chambers and also connect the tube sections together when we build the tube. In this station, they're welding the nose cones. The nose cones come, like the sidewalls, a flat sheet of flat stock aluminum, varying wall thicknesses, but again, everything is 50-52 alloy and H36 hardness. We'll roll it, crimp it, then we'll put it into these stations here. As you can see, use those hydraulic arms to collapse the edges, and they'll be welded from tip all the way back, again leaving about 4 to 6 inches at the other end of the nose cone, so we can insert a baffle between the nose cone and the sidewall. Once that welding is done, they're going to hand form this piece of keel. It starts off a straight piece of keel. They're going to hand form that to match the contour of the nose cone and cover up that weld, and that will also be welded. I mentioned before the robotic welder leaving some space at the top and the bottom of each tube section. That's so they can put the tubes and baffles in place. He's going to tack weld the baffle to hold it in place, and then he's going to hit his foot pedal, and the tube is going to start turning, and as it turns, he's going to weld on it, welding the baffle 360 degrees all the way around the tube. We'll do the same thing with the end cap, and we'll do the same thing with the nose cone when the nose cone is added. In the instance of an elliptical tube, it goes through the same process. We're just starting with a larger piece of aluminum. It's going to get rolled and seam welded the same, but then it's going to be put in this compactor or compressor that's going to hold the shape of the elliptical while we put a stiffener in the belly of the tube to add some rigidity, and also It holds the shape while the worker puts the baffle and end cap in place. Again, we're making tube sections, and then we'll put the sections together to create the tube. You see, again, everything is on rollers. As the tube section is rolling, he's welding the baffle into place. Once the tube sections are done and staged, this group is going to then put the tube sections together. You'll see the baffle on this section has about 3/4 of an inch of an overhang, and the open end of this tube section is going to slide over this overlap, and then again, everything is on wheels. They're going to start to roll it and weld it as it's rolling. Then they're going to weld a hole or burn a hole into each section independently, where we can weld a threaded aluminum coupler. That's going to allow us to pump air into each tube section and do an air test to make sure there's no leaks. Once it passes the air test, we'll put a nylon plug in that coupler, which the dealer can remove later if they ever have to do an air test in the field. The next station is our M brackets. Our M brackets are all pre-punched and fixtured, so they're all very consistently placed on the tube. A couple of key features of our M brackets are these aluminum feet that match the radius of the tube. That gives us more aluminum to actually weld to the tube. The location of the M bracket is on top of the end cap. The end cap has about a 1-inch lip that goes underneath the sidewell. The M bracket is on top of that. For the same reason, the keel extends beyond the end cap at the bottom of the tube. The reason we do that is if the boat is sitting on the concrete or in storage, we don't want the weight of the boat pushing the keel up into the tube or pushing the M brackets down into the tube, creating unnecessary stress on these welds. So it's a very subtle point, but very key to the construction of the stern of the boat. Another key feature is as the M brackets get taller, there's actually more aluminum near the corners of the end caps where they could potentially fold. More aluminum on the vertical planes, spanned out wide across the top of the tube to distribute the weight evenly across the tube, and very low profile, about 1.5 inches of space between the top of the tube and the bottom of the deck frame. That wide, low stance helps reduce the opportunity for twisting or buckling in rough water or in trailering situations. Once the tube is done, we're going to air test each chamber independently via the aluminum couplers that we spoke about a few moments ago. Very simply, we're going to pump some air pressure into each chamber, do a visual inspection by spraying, very simply spraying soapy water on all the wells and doing a visual inspection for bubbles. If there's a test failure, we find a leak, we'll send it back over to the welders. It'll be patched and retested before it ever leaves this building. The last thing we'll do in this building on a center tube is we'll weld the transom into place with some heavy-duty aluminum and backers and some gussets. Here's the aluminum stiffener that I was talking about earlier on the elliptical tubes. And it'll cut the access for the storage with this plasma cutter and a template to put a subfloor where the storage goes. Once the tubes are complete, they'll be brought over to the main assembly building where they'll start to put the deck frames in place. All the M brackets are all pre-punched. All the cross channels are pre-punched. That eliminates a lot of the human element with drilling, maybe misdrilling, so we punch everything ahead of time when the item's being extruded. So we have much better consistency and control over the product. 1/4-inch vertical cross members, 3 inches tall, 1/4 inches thick on the rear cross members. As you go forward away from the load-bearing part of the boat, they get a little thinner, so a little bit lighter weight, so the boat naturally sits stern down, bow up by a couple of degrees. Once the deck frame is in place, we'll spread foam tape across each cross channel to help reduce the vibration from the engine and also help to create a seal between the aluminum and the wood on a 2-tube boat that does not have a wave shield. A couple very important parts for an inexpensive part of the boat. Once the deck frame is in place, we'll bolt on the plywood deck. We'll drill up from the bottom with a 1/4-inch bit, then use a countersunk drill to drill down to the top to create a little depression for this elevator bolt that has the teeth that bite the wood. Use a specialty bolt, flat, low profile head with these fangs that bite the wood that allow us to use a nylock nut instead of a kept nut or a lock washer. After we've drilled it, countersunk the hole, pounded the bolt into place, tightened it via a nylock nut, we'll go through and patch all the depressions that we made with some wood filler, sand it so it's all smooth, sweep it off or blow it off before we apply the glue for the floor covering. Once the floor is done, we're going to roll out about 4 gallons of glue on each deck with these paint rollers. Roll the glue out evenly, then roll the floor covering out. Use a heavy rolling pin to make sure we have good adhesion throughout the deck before we start applying the deck trim. Another key component of our deck frame is the bow crossmember. The bow crossmember goes all the way from side to side and wraps around underneath the deck about 1 foot aft of the bow. Another key feature of our bow crossmember is it's actually taller than the deck trim. It has about a 1/4-inch lip on the bottom of it, so that when we lift this boat up with a forklift or a scissor lift, it's picking using the heavy cross channel, not the deck trim, to lift. Also fortifying the corners, because we know that's the most frequently damaged part of the boat, is the bow corners when you're approaching your dock or when you're approaching your trailer trying to pull out. Once the deck trim is installed, we'll put the rail fencing on. You notice that each cross member is marked. That's so we know where to drill to put our fastener through, a 5/16 fastener that goes through the deck trim, through the wood, then also through a cross member underneath the deck. These are things that a lot of times the customers don't know to look for, but they're there to make the rail solid. Again, a 5/16 diameter bolt instead of a 1/4-inch diameter bolt like a lot of our competition uses. Also, you'll notice on the inside of the paneling, you don't see any rivets. Everything is machined and crimped into place. That gives us a nice tight fit. No rivets to vibrate free or fasteners to vibrate free. Everything is machined and crimped into place. After we put the rails into place, we'll start to hang the wiring harness that goes from the helm and the battery throughout the boat. Gets power to all your lights, your horn, all your speakers, and so on and so forth. Every connection under the deck is a Deutsch connection with a gasket and a clip-in Deutsch. Then we'll install the furniture, hook up the speakers, install the console, run all the cables from the console and the helm back to the motor pan, run all the wires from the helm to the speakers and lights and throughout the boat, everything that needs power. Once the console is installed, the rest of the production line is mostly cleaning, inspection, and repair. We're going to do an electrical test. We're going to test the fuel system for air pressure, make sure there's no leaks. If there's anything that's damaged or needs attention, our inspectors will mark it with a piece of red tape. Then our final finish crew will correct whatever it is that needs attention. Then at the end of the production line, once cleaning, inspection, repairs done, it's prepped for shrink wrap. And then finally, the last thing we do in this building after the boat is shrink wrapped is if it gets a wave shield because of the running surface or the production order line items calls for wave shield, we'll put the boat on these automotive hoists, work underneath it to put the wave shield on, then it'll be staged for shipping. And that's pretty much the end of the general production. Thank you. Hope you enjoyed it.